I did mention chapter 2 is primarily on linear relations and functions. So yesterday was just a review of what a relation and a function was, and now it's tying into what's actually linear. So linear relations are relations whose graphs would be straight lines. Nonlinear would be not linear. So just that vocabulary. Linear equations. These are equations that contain no operations other than addition, subtraction, and multiplication of a variable by a constant. So notice division, specifically division by a variable, is not in there. So I have some bullet points listed there of things that either linear equations could contain or could not contain. But in a linear equation, this means that variables may not be multiplied together. So it's just multiplication of a variable with a constant. Variables may not appear in the denominator of a fraction, so no division by a variable. No variables contain exponents other than 1, because if you do have, like say you have x squared, that would mean you have an x times x, which means you have variables multiplied together. So it's for that same reason as the first bullet point, variables cannot be multiplied together. And then the graph is always a straight line for a linear equation. And then there are some examples here of linear equations, non-linear equations, but we have our own examples down here too that we're determining if they're linear. So I don't want to, I mean, that's a reference for you, but I don't want to talk too much about those. Notice even the ones that are written as linear equations are in different forms. They're not all in the same form. And then a linear function is a function with ordered pairs that satisfy a linear equation. So that would mean ordered pairs satisfy everything up here. When it's graphed, it's a line, so it's a linear function. And then linear functions can always be written in this form, which, what is the name of this form? Usually you see it like this. It has to do with slope. Slope something form. Slope intercept form, yes. Why is it called slope intercept form? What does the M stand for? The slope. What does the B stand for? The y-intercept. Okay, I just point that out in case if you didn't make that connection before. The names of the forms, because there's slope intercept form. The only one is standard form. That doesn't really, I mean, we're covering that today too, but slope intercept form and then point slope form. The names of those forms tell you the two things that you need to know to write it in that form or tell you what that form contains. So slope intercept form has your slope and your y-intercept. So yeah, it's saying all linear functions can be written in that form, and notice the function notation is used. So under example 1 for these 6, we're just stating if it is a linear function, yes or no, and then explaining. Explanation would be, well, I'll go through this, but if you're saying yes, it's because you could write it in this form, so you can identify a slope and a y-intercept. And then no could be any of these reasons above, that it contains something that a linear function or equation should not contain. So if we look at A, we have f of x equals 8 minus 3/4 x. Would you say that's linear? And it could be, because of the way these are written too, with the function notation, well, just in function notation, if it's already written in this form, you know it's linear. So is this in slope intercept form? I see some yeses. Maybe you're not 100% confident, but yes, it is. So the negative 3/4 x, that's your mx, and then the 8 is your b. So I'll just say yes, because it's written in slope-intercept form. And if you wanted to write here, because we're not really identifying these much today, we're not graphing in slope-intercept form, but just to get in the habit of doing it. So your slope would be the -3/4, and your y-intercept, your b, is the +8. So the terms are just how they normally are. What about b? F of x is equal to 2/x. Jasmine, I saw you say no. Why'd you say no? Yes. So no, because there's division by a variable. Oops. So linear equation should not have division by a variable. Division by a constant, by a number, is fine. C, now this one's written a little differently. This function notation here, g of xy, what that tells you is on the other side of the equal sign, you see both variables x and y. So that's why that is written that way. So this notation really tells you what your variable is on the other side. So we have 3xy minus 4. Would you say that's linear? No, why not? Correct. So no, because I'll say there's a product of variables. You could say there's, variables multiplied together.
Junior. Are you a junior or a sophomore? Junior. Okay, I'm a junior. And then Lucy's the juniors. Okay, 3 juniors. And then the sophomores, 1, 2, 3. Wait, Lucy, you're a sophomore. I'm sorry. Okay, Lucy's a sophomore. Okay, I think you got everybody right. Oh, are sophomore, freshman? Freshman? Okay. Thanks.
All right, what about D? P of x is x cubed plus 2. Linear, yes or no? I heard a no. Why not? Correct. So no, because I'll just say x is cubed, but Sadie, you gave a good explanation. With x being cubed, you have 3 x's multiplied together. You can only have one variable, not multiple variables multiplied together. Should be highlighting here too. Here's our product of variables, x cubed. E, 5/x plus 6. Linear, yes or no? You heard a no, why not? Yep, divide, there's that variable, so same as B. I'm just gonna kind of do this because it's notes. Don't do that on a test, but with notes, same reason, no, because there's division by a variable. Division by a quantity that has a variable in it. And then F, we have g of x equals -3/2 x plus 1/3. Linear, yes or no? I heard some yeses. So yes, with fractions, not all fractions are bad. These don't have variables in the denominator. This is slope-intercept form. So yes, because it's in slope-intercept form. Slope would be -3/2. y-intercept is 1/3. Okay, questions on those? Okay, then example 2, this one I'm actually just going to have you work through because we've worked through problems like this and I'd rather you take a look at it before we go through it. So you have the growth rate of a sample of Bermuda grass is given by the function, so you're using this function. And then always pay attention in these problems, it tells you what the variables represent. Remember, f of x is y, it's just like a y value. So it's saying f of x is representing the total height in inches, x is representing the days after an initial measurement. So f of x is height, x is days. A asks you how tall is the sample after 3 days, and then B asks you if the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? So go ahead and answer those and then we'll check them and move on to standard form. All right, we seem to be okay, but just double check. Well, actually, because some of you were still kind of working when I was walking around too. So for A, how would you solve for A, Alexis?
So f of x would be f of 3 is equal to 5.9x plus 3.65. So you substitute 3 for x and then you can solve for 3 solving for that.
Okay, so X would be 3. And then what about for B? How would you solve B? Some of you didn't have B quite done when I walked around. Isaac? Solving for X, yes. So you should have f of 3 in part A, 20.95, which if you had A done when I walked around, that's what I was seeing, 20.95 inches. And then yes, you're putting 50.45 in for Y, which is going in place of the f of X. You're just replacing that. And then solving that equation for X. So that would be 8 days. Questions there? So always, you guys seemed fine, but just pay attention to what variables represent what units so you know where to substitute things in. We'll move on to standard form. Okay, so standard form for a linear equation is the form ax plus by equals c. and the a, b, and c are capitalized in that form. You did see this in Algebra 1. A, b, and c are integers. So let's stop there. Integers, what does that mean exactly? What are integers? Because we covered that in Chapter 1. Or what are not included with integers? Fractions are not integers. Yeah, positive and negative whole numbers are a way you can describe integers. So fractions are not included. Decimals, I think I might have heard, are not included. But positive, negative numbers, and then just not fractions or decimals. And then they have a greatest common factor of 1. And your a value has to be greater than or equal to 0, meaning your a value must be, if it's not 0, it has to be positive. A is the only one that has to be positive. B and C can both be negative. And then A and B can't both be 0. And the reason they're saying that, if A and B were both 0, then you wouldn't have a variable, which means you wouldn't have a linear equation. So it gives an example here of an equation in standard form. It gives you A, B, and C. So we're going to write each of these in standard form and identify A, B, and C, but it has to meet this criteria. So if we look at example A, I always look at, first of all, moving my terms around if I need to. So notice in standard form, you want the x term first, then the y term, then equals, and your constant term on the other side. So the way this is right now, I want the x term over on the same side as the y term. So I would move that over by subtracting it from both sides. And I'm going to write it in front, because again, you want your x term first. So I have negative 4x because I subtracted it. The 2y was positive, so plus 2y, and then equals, and I still have a positive 5. And now that I have all of the terms where they need to be, then I double check that I've met this criteria. So I do have all integers. I don't have fractions or decimals. Greatest common factor of 1. That just means if you notice that all 3 of your values, A, B, and C, can be multiplied by, or multiplied or divided, I should say divided by the same number. Like if these could all be divided by 2, then you should do that. You should divide everything by 2 so that it's in its simplest form. I can't divide 4, 2, and 5 by anything besides 1, so I can leave those. But then my a value has to be positive. Right now it's negative. How would I change this so that it's a positive 4x and not a negative 4x? Yes, I can divide by negative 1, and that means I have to divide everything by a negative 1. So I have to change the sign of everything. Or you could also multiply by negative 1, same thing. So I would get a positive 4x and then minus 2y equals a negative 5. Now I've met all the criteria. This is my standard form. My a value is the coefficient of x, so 4. My b value is the coefficient of y, which is negative 2. Oops, not the y. And then my c value is the constant, which is negative 5. Okay, so rearranging the terms, again, that's usually where I start. But depending on the problem, sometimes you might start in a different place. It doesn't really matter. And then I double check that I have the right A, B, and C, that it meets the criteria. So if we look at B, again, I would kind of get my terms in the correct placement. So I would want the y term on the same side as x. So I'm going to subtract 8y from both sides. So I have negative 3/10 x minus 8y equals, and I have negative 15. And now here, though, I don't have all integers because I have this negative 3/10. So what could I do to get rid of that fraction? So think of when we were solving equations before, how do we get rid of the fractions? Yes, multiply by the denominator in this case. Or if there were multiple fractions, common denominator would work. So just multiply everything by 10. I like that Sadie said negative 10, because then that also takes care of the negative right away also. So I want to multiply everything by negative 10. So for my x term, it'll now be positive. The 10's cancel, and I have just 3x. For my y term, negative 10 and negative 8 is a positive 80y. And then negative 10 times a negative 15 is a positive 150. And then the only thing you'd want to check here, because I now have integers, I know that a is positive, but the greatest common factor, I would just see, is there a number I can divide all of these by? And really the only number I should check is if I can divide everything by 3, because of this 3. Can I divide 80 by 3? I see some no's. I can divide 150 by 3, but not 80. So then this is my standard form. My a is 3, b is 80, c is 150. All right, questions there? Okay. Then the last example is a way that we often forget about using to graph lines, because we get stuck into graphing using slope-intercept form, and this is graphing by using the intercepts. So it says, since 2 points determine a line, one way to graph a linear function is to find the points at which the graph intersects each axis and then connect them with a line. So the y-coordinate of the point at which a graph crosses the y-axis is the y-intercept. The x-coordinate of the point where it crosses the x-axis is the x-intercept. So we'll just go on to example 4. So it says find the x and y intercept of the graph of this equation and then graph the equation. So you don't have to rearrange this equation at all. It's not in really any specific form here. You don't have to do anything with it. So if I were to find the x-intercept, when you have a graph, we'll have to graph this also. So here's my x-axis. The horizontal axis is my x-axis. Think of any point on the x-axis. What is the y-coordinate of any point on this line? 0. So to find your y-intercept, you're replacing the y in the equation with 0 and solving for x. So I often hear, I'm just going to rewrite the equation here. But I often hear like, oh, you cover up the y and then solve for x. The reason though you're covering up the y is you're replacing it with 0, because that's what that y coordinate is going to be. So if I put 0 in for y, 2x minus 3 times 0 plus 8 equals 0, then it does make that term just go away, because anything times 0 is 0. So I really just have 2x plus 8 equals 0. Solve for x. So subtract 8, 2x is negative 8, divide by 2, so x is negative 4. So if I ask you for an x-intercept, it is fine for you to just say x equals negative 4, or you can write it as the ordered pair. The x-coordinate is negative 4, the y-coordinate is 0. Okay, so either of these forms is fine, but if you just say negative 4, that's correct. And that means on my x-axis, I didn't include a coordinate plane here, so you'd have to just sketch your own. But that means I can sketch where negative 4 would be on my x-axis. That's my x-intercept. So I would just plot that point. And then I'm finding the y-intercept in a similar way. So for every coordinate on the y-axis, just the opposite, the x-coordinate is 0. That is the line x equals 0 here. So in my equation, I replace x with 0, solve for y. So I have 2 times 0 minus 3y plus 8 equals 0. So my x term is gone. Make sure you keep the negative in front of the 3y. And then if I subtract 8 and divide by -3, I'll get a positive 8/3, which I'm going to leave as a fraction. If you wanted to write it as, this would be 2 2/3. Okay, so giving that as your answer or putting it as an ordered pair, the x-coordinate is 0, the y-coordinate is 8/3 or 2 2/3. And so if I plot approximately where 2 2/3 would be on the y-axis, that's my y-intercept. So just make sure, because I've seen this happen, that you're not taking these two values, the x and the y-coordinate, and putting them together as one point, because then you can't draw a line anyway. You'd have a point right here, and there's no line to draw because you only have one point. So these are two separate points. They're not the coordinates that form one point, and then you just draw your line through them. Okay, so finding intercepts is a way to graph a line. I find this method helpful when you have equations that have very large numbers. So we'll have some of those. Otherwise, I know like this equation you could probably put into slope-intercept form and graph it that way too. But this is a method we often forget about using. So we'll use it here and there throughout.